Hello and welcome! In this lecture we're going to build our grid object class. This is the object that will be instantiated in every single one of our grid positions. Okay, so let's begin making our new C# script. So let's right click on the script, a new one, let's call this the grid object. And here, first of all, just like we did with the grid system, let's get rid of mono behavior. We want to be able to use the constructor. And right now we don't have any specific requirements. In the future this object will contain a list of all of the units that are in this grid position and so on. But let's start off simple by just storing some basic data for this object. It will probably be helpful to know which position this object belongs to. So a simple private grid position for the grid position. And it will also probably be helpful to know which grid system created this object. So maybe a private grid system for the grid system. Okay, now let's make a constructor to set these. Make the constructor public so it can be called from outside. Here we receive a reference to the grid system and the grid position. And just store them. Okay, this is good for now. We have a nice amount of information for every single grid position. Now we need to actually create one of these objects for every single grid position. So let's go back into the grid system script. And over here we're cycling through the X and the Z. Let's get rid of the debug draw line, we don't need that anymore. So here what we do is we create a new grid object. For parameters, let's pass in this for this grid system, and then for the grid position, let's create it. So grid position, we just make a new one with this X and this Z. Then here we just use it. Okay, so just with this we should have grid objects being created, but right now after being created they're lost forever, we're not storing the reference. So obviously we need to store them in some way, and for that we can make a really nice two-dimensional array. So let's go up here, let's define a private, it's going to be of type grid object, and we're going to want to create a two-dimensional array. So we open the rectangle brackets, then a comma and close. This is how you define a two-dimensional array. By adding a comma here, you are defining this as an array with 2 dimensions. And let's call this the grid object array. Now if you're not familiar with 2D arrays, it's actually quite simple. They are pretty much exactly the same as a normal array, but you have 2 dimensions. So on a regular array, you can create it with a certain size, and you can access each element based on its index position. So for example, accessing the array on index 1. Then on a 2D array, it's pretty much the same thing, except you have 2 dimensions. So you create it with the size for the first dimension and then the second one, and you access it by providing the index to both dimensions. So something like index 1, 0. It's easier to understand if we see it in action, so let's do it. Then before our cycle, let's create it. So grid object array equals a new grid object array. Then here we input the size, so we want it of size width and height. Okay, it's created, and finally down here, let's set this one on index xz. Let's put it with this grid object. Okay, great. So with this, we have all of our grid objects being created. However, like this, it's a bit difficult to verify that. These objects have no visual, so it's quite difficult to inspect what data is on what grid position. So let's sort that out by making some debug text fields. Let's make a function to create it. So down here, let's make a public void, call it create debug objects. And the reason for making this public is we're going to call this from our testing script so we can create a grid and then decide whether or not we want to also create debug objects. In this function, let's receive a parameter which will be the prefab. So we're going to receive a transform for the debug prefab. Then let's just cycle through the X and Z, so we can actually just copy this. So cycle through the X and the Z, and then for every cycle, over here let's instantiate. Now since this script does not extend mono behavior, we can't directly use instantiate, so we need to use gameObject.instantiate. Then the object that we want to create, so let's do our debug prefab. And for the position, let's get the world position on this X and this Z. And finally for the rotation, we don't want any rotation, so let's use quaternion.identity. That is basically the constant, which means no rotation. Okay, so that's it. And by the way, one quick note here on transforms versus game objects. Here I added this parameter of type transform, and down here I'm calling instantiate. I could instead have made this of type game object, then down here instantiated just the same. Both those types are different, but also pretty much interchangeable. The reason is because every single game object always has a transform, and every transform always has to be attached to a game object. The main difference is when calling the instantiate function. If you instantiate a game object, then this function returns a game object, Whereas if you instantiate a transform, then now this function returns a transform. Now for me, usually when I instantiate something, I tend to move it or scale it or something. So if I wanted to do that here, I could just store the transform. So for the debug transform, I could just store this directly and then do debug transform dot position, set it to something and so on. Whereas if I made this type of type game object, then this would return a game object. So I'd have to have the game object. And through the game object, then I would have to access the transform. So basically I'd have one extra step just by adding this of type game object. So by instantiating the transform directly, it helps cut down the transform access. And of course, like I said, all transforms are attached to game objects. So even if I go with the transform route, on this one, if I want the game object, I can just access the transform.gameObject. So that's just a quick note on transform versus game objects. When it comes to prefabs, you can really use whatever type you prefer, and personally I tend to use transforms. Okay, so with this we have our prefab being instantiated on every single grid position. Now we just need to call this function, and for that we're going to need our prefab. So let's make that visual prefab. Here in the editor, let's create an empty game object. Let's call this the grid debug object. Then inside it, let's create a new 3D object. Let's go with a text object. And since this is the first time we're using a TextMesh Pro object in this project, then this window appears. So let's make sure to click on this button in order to import the TextMesh Pro Essentials. Okay, that's it. That just imports the basic assets that TextMesh Pro needs to work. The examples and extras, those are optional, so there's no need to do that. Alright, so here we have our text object. Now we want to make it aim upwards. So on the inspector on the transform, let's rotate on 90 degrees on the X. And here we actually have the same issue that we saw previously with the rendering collision. So if I put the grid debug object on Y of 0, yep, we see the exact same issue. So let's use the exact same solution. So let's put it on a Y position of 0.02, just so it's also different from the unit selected visual. Okay, now let's just play around with the font size. So we're going to want to say the X and Z. Let's scale the text to make sure it occupies one grid position. So for the options on the rect transform, let's set the width and height to 0, 0. Then down here on TextMesh Pro, under alignment, let's put it center and down the middle. And then for wrapping, let's disable it so everything works. And finally for the font size, let's make it quite a bit smaller. So like this, I think it looks good. So with the font size of 5, and yep, we're going to place our grid debug object something like here, and then say the grid position. Okay, now let's make this into a prefab. So let's go into our prefabs folder and just drag and drop and delete the prefab from the game scene. Now let's go into our testing script, and over here we need a reference to that object. So let's make it a serialized field so we can set it in the editor, private of type transform, and let's call this the grid debug object prefab. Again, like I mentioned previously, you can make the reference of transform or a game object. Either one will work, just make sure you use the same one that you used on the create debug objects. So we've got the reference, and after we create the grid system, let's call our function. So grid system.create debug objects and pass in our prefab. Okay, so with this we should be seeing debug objects on each grid position. Let's just make sure we drag the reference in the editor. So let's select our testing game object, there's our field, and let's drag the reference. Okay, so let's test. And yep, there they are. All of the grid debug objects on each grid position. Okay, so far so good. Now obviously we want them to display the inner data for each grid object and not some random number on every single one of them. So in the next lecture we're going to create a custom script to run our custom grid debug object.